Good morning. We will wait just a little bit longer for others to join. Just a few more minutes. We've got people still trickling in. Hello, everyone. We can go ahead and get started. And anyone else that is interested in joining, they can join as we continue on. I'll make an introduction of PowerSafe, and then I will switch my screens to share the PowerPoint training for today and get going on that. And then we'll have a Q&A session at the end. But if you have anything along the way, you can drop that in the chat. We have someone that's monitoring that. For us, it's the afternoon. I know some of you are global companies. We are actually in Germany right now hosting this. We have a customer that we're visiting on site. for designing a machine that they're building, and it will be shipped over to the U.S. and we'll do the installation in the United States. So just wanted to share that for anybody that has any global business that you're interested in looking at for machine safety as we talk through this. So my name is Sean Mansell. I'm the CEO of PowerSafe Automation. I've been in the market for about 32 years. Started out in the T-slotted extrusion framing business and then moved into machine safety and started PowerSafe Automation about 10 years ago, offering a turnkey solution that is assessments and custom design, manufacturing, assembly, and the installation and integration, mostly focused on legacy machines dating from 2000 all the way back to the Industrial Revolution, with whether it's full risk reduction on machines, if it's risk reduction for partial, depending on the age of the machine. We have seen a lot of different types of machines. So as we go through this, if there's anything that we can help you with when we get to the end with any questions, or after we get off and you want to schedule a call or a Teams meeting, then we can go ahead and do so. So I'm going to go ahead and share my screen and we can go ahead and get going. So again, PowerSafe Automation, we focus on engineering your safety. This PowerPoint is going to be focused on the engineered solutions and not on the administrative controls. The training presentation that we work through with machine guarding is based on risk reduction measures. When you are dealing with legacy machines, from an engineered solution standpoint, it's virtually impossible to mitigate and have full compliance on machine safety. So we have to be careful when we talk about, is this going to be OSHA compliant? Does it meet all the ANSI standards? That can be a tricky question because these machines were either designed before OSHA or they don't have the infrastructure in them to have the proper redundancy that's required in today's methods and standards. So we want to be looking at risk reduction. If you want to try to go full compliance where an employee is 100% safe and you don't want to trust them through administrative controls with PPE and signage and things of that nature, then you're starting to look at mitigating it with automation, putting a cobot in, part shuttles that go in and out of a cage. So risk reduction is what we focus on from an engineered solutions. You may be able to get there with compliance when you are focused on trusting employees with the signage. Are they going to read a sign to don't stick your hand here, or this is hot? Are they wearing their PPE? But engineered solutions, a lot more companies are going in that direction today. Start out by defining machine standards, regulations. Just to give you a quick overview, we won't go into a lot of details of all the different codes, but everybody knows OSHA. You've heard that name. It's the most common is the 1910.212. There's others in there when you get into bench grinders and machine tools and things of that nature, but this is basically the regulatory codes to help you police your machine guarding. So you are required to have machine guarding on, protect your people, and there is no grandfather clause to not guard your equipment. If you've got a machine that predates OSHA, you still have to guard it. You still have to protect your people. There's tools out there that we'll get into that will help with this, but regardless of the age, it's still our responsibility to make sure that we protect our employees. And then ANSI is the set of standards that help you design machine guarding that really keeps you from let's call it getting in trouble by OSHA. Helps you protect your employees. These are a set of guidelines that you can use, that there is gray area in these standards because of the type of operations on these machines, how you use your machines. But you have to also look at best practices, not just, well, is this minimum OSHA requirement? Is this the minimum ANSI standard? Even if the answer is yes, best practices put you over that line for the engineered safety. Maybe a little extra redundancy, maybe a little overkill. But these are the two main areas from the physical standpoint. And then we get into the electrical codes and NEC and NFPA, the electrical codes and electrical standards that work hand in hand with the physical guarding portion of machine safety. The goal is to mitigate hazards by stopping the machine, slow speeds to a safer feet per minute, or moving hazards to a safe position. So as we go through, I'll share best practices, some regulatory stuff, and things of that nature. The next thing I just want to share, you see these signs all over factories. These are some of the most common injuries out in the factory. You'll see these signs. Again, people look at these signs, they've become white noise. They've either gotten dirty, they're falling off, they're covered up by another sign. People don't understand what they mean because it's just a picture. And then you can see pinch points, crush points, shear points, all across the board of some of the most common injuries. Lacerations, fractures, hopefully it's just that, not that they're good, but if we can at least minimize it to those areas, and we need to make sure that we're hitting the highest risk first for the amputations and the fatalities, and then work our way into the fractures and laceration areas. Just something to share. Most common injuries are found when cleaning, adjusting, or clearing jams. So when you look at an operation, talk to operators, ask maintenance, what do you do when your machine jams? Are you stopping it? Are you locking it out? Do you think you're faster than the machine? So I'm going to go try to grab that. When you're cleaning, did the roller grab your rag and you reflex and you go to grab it and then you get pulled into the rollers? Adjusting it, the film isn't cutting right, or the paint isn't right, the box isn't folding correctly. So I'm just going to make some little adjustments. So I'm going to lean in, and now I'm exposing myself to even a greater hazard. So those are the three most common injuries. So if you focus on that will hopefully help a lot when you're looking for hazards to mitigate. Different types of machine guarding configurations. When you're looking at how to do that, you got to look at the hierarchy of controls. Again, we focus on engineering controls and not the administrative controls and the PPE. Elimination and substitution, that is going to be where I mentioned bringing in automation. If you want to try to substitute it with work holding fixtures, or a cobot or robot, or just eliminate it altogether by not even running that part, or you take it off a manual machine and you put it on a CNC and it's fully programmed. So today we're focusing on the engineered controls. That is the most common. It's expensive to try to eliminate and substitute. Sometimes you can do it, sometimes you can't. Sometimes it takes a long time to develop an automated machine for your operation. And then honestly, when you're dealing with administrative controls and PPE, now you're trusting the human to make the right decision. And with these OSHA injuries being in the top 10 year after year after year, people aren't making good decisions, or they're not trained properly, or they're so new They don't have the mechanical ability. They've never worked in a factory before. They'd only been there 2 days. So we really want to focus on engineering controls to try to take the human element out and let the machine make the decisions. So in doing that, you have three main components. You have the machine guarding. Minimum requirements for guarding is a tool to remove. Fingers, hands, not a tool. So you have to bolt it on. If you don't want to bolt and unbolt all the time because you're accessing it and you want to add doors or you want to add light curtains, safety scanners, whatever that is, then you can add an electronic safety device. A machine guard, in my opinion, is not a safeguard without proper electronic signal. Again, you want to make your machine guard intelligent, and by doing that, you add an electronic signal that talks to the machine instead of the human talking to the machine. And then you let the machine and the guard make the decisions whether the operator can have access or not. And then you have to have safety rated monitoring controls. This is your redundancy. So it's basically sending signals back and forth, asking questions digitally. Are you okay? Are you still working? Are you in failure mode? If no, I'm not in failure mode. I'm still running okay. Okay, keep running. No, I'm failing because my redundancy of both channels, both lines of communication aren't answering me simultaneously. I'm going to stop the machine. And we'll get into that a little bit later. But these are the three main areas to focus on for engineering controls. Now I want to get into the different types of machine guarding that you can use. Most common that we use or we see out there would be the T-slotted aluminum, the steel guarding, and fabricated metal. The T-slotted extrusion, very handy for point guarding, customizable when you have custom machines, custom fixturing, inputs, outputs of materials, tunnels, whatever that is. You can use the extrusion for cut it, bolt together. If you need to modify it, you can reconfigure it. So this is very common for machine enclosures that are right up at on the machine. The steel guarding is most common when you're looking at doing perimeter guarding around work cells, production lines, a machine that you need to get inside and walk around. So the yellow posts with black mesh is very common for those. And then fabricated metals, a little more unforgiving when you use those types of guards. But if you need a lower profile guard, then you may want to look at using something that's fabricated, thinner metal on those type of machines. Most common panels then, once you've decided what is my framing going to be, it's going to be black wire mesh. Some people have used yellow wire mesh in the past. You can't see through yellow. There are studies that have been done that yellow, looking through it, will actually give you headaches. So when an operator is trying to see what's going on inside, you think, well, let's put yellow mesh there because that's safety. Well, it'll give them a headache. They won't be able to see the parts. They won't be able to see what's going on. If you're going to use yellow for some identifier, your framing should be. You can powder coat your extrusion yellow if you want to. Most don't, but you can. There's a yellow T-slot cover strip that can go in the extrusion, or the yellow posts on the steel guarding, but black is your most common. And then polycarbonate panels and black ABS panels. So the black ABS would be for things that you don't want to see through, or if you want to hide dirt on the bottom half of the guard and see through the top. But the clear polycarbonate is most common for a solid panel that you want to see through. Make sure that it is polycarbonate or Lexan, which is impact resistant, not acrylic or plexiglass. It's very common for people to say, well, just put some plexiglass in there. That shatters on impact, so that cannot be used as a safe panel when you put when you put this around your machines. Connection methods, handles, hinges, accessories, mounting methods, all kinds of different options there. Try to keep it simple. How am I going to connect my framework together? What am I going to bolt it together with? How do I close off the ends so I don't have sharp edges? It's clean look. How am I going to swing these doors, latch these doors? How am I mounting it to the floor, to the machine base? There's a lot of detail that goes into finishing how you're going to create these guards. But for the most part, pick out your framing, pick out your panels, and then pick out how you're going to put everything together and put it on the machine. When you're determining what that's going to look like with your panels, you need to figure out where your hazards are in reference to your machine guarding. Everything is based on openings. So if your wire mesh is 1.25, you need to be 7.5 inches away from the hazard. There's a thing called a gotcha stick that you can actually stick through the opening in the guard so that it can tell you if your guard opening is too big. If your hazard is right inside the guard, you may have to go polycarbonate where there's no holes. If you've got the luxury of a little bit of room with 1/2-inch wire mesh you could use. So if your machine still needs to breathe, or you want to see through the mesh instead of going through looking through polycarbonate, maybe your polycarbonate will get dirty fast. Maybe you need to stick an adjustment wrench through the wire mesh, but you need to use the gotcha stick, tape measure, whatever that is to figure out what your hazard is. What you don't want to do is you don't want to start modifying your guards because it's convenient for, hey, I've got a new product I'm going through and putting through here, or machine keeps jamming all the time, so I'm just going to cut out a bunch of the wire mesh. Well, now this opening, way too big. Anything over this, you have to look at being, I think it's over 4 inches. You need to be 36 inches away at least. So when an operator cuts this open, they can stick their whole arm in it, maybe half their body, stick their head in there. So we have to make sure that we're constantly looking at making sure these are not modified. If we need to make this bigger, then there's designs that we can do with adding tunnels to extend your reach to be able to get to the hazard and still have your full accessibility just over here and not over here. The other thing to factor in, not just through, it's going to be an acronym that I use called AUTO: around, under, through, over. Very commonly, up to this point, a lot of people have focused on just straight through. Well, if anybody falls, tries to reach, they're not going to get to the hazard. So because I have guarding there, I don't need to guard around it, under it, over it, because no one would reach, no one would try to crawl, no one would climb over. Why would anybody do that? These are a lot of conversations that we've had with people. Why would anybody do that? Regulations exist reactively because somebody did it. So when you're looking at machine guarding on your floor, just ask yourself, does this meet AUTO acronym? Minimum height requirement on machine guarding is 55 inches. So if you have guarding that's at 42 inches, that technically is pedestrian safety. That's going to be a handrail or guardrail. If it's machine guarding, then it needs to be 55 inches tall. Typically, we see things between 6.5 to 7 foot tall, and then a sweep underneath for someone not to crawl under would be 6 inches. And then you have to shore up the gaps on the sides. So A, U, T, and O. So this graph here shows you leading injury factors. So it's a chart. Percentages reflect averages, annual U.S. injuries from guarding related accidents. So reaching past or around a guard, the auto that we just talked about. Someone would reach around it or reach through the opening that I showed you that someone cut open. Maybe somebody removed a guard and either they lost the screws or didn't have time to put it back on. I'll put that back on later. So they've removed it during operation. They're climbing on it. But handling dropped oversized heavy guards, large one, make sure that your guards are designed in manageable sections. If they are removable panels, if they're hinges, then maybe you put a caster on it so the door doesn't sag. If it's a removable panel or sections that you have to take off for maintenance, make sure you design those properly. So this is a good representation of the things that you should be looking at when you're looking at your hazards and where should I start. That's a one that people get crippled with too many decisions because there are so many hazards, whether you see them or not, and they don't know where to begin. So these can be some tool. This could be a tool that can help you in that respect. Then we move on to electronic safety devices. You had your machine guarding, and now we have the electronic safety devices. Some people will call it e-safety, just for short. Includes components with redundant safety rated channels. OSSD, it basically is an electronic signal that talks to your machine that has the redundancy. Think two parallel lines to a finish line. If you and another person are racing to the finish line and you're running simultaneously and you cross the finish line at the same time, that is what these signals are looking for. Because if one is lagging behind, there's a problem. If you both can't make it to the finish line at the same time, why not? Did you not train for it? Did you get overheated? Are you just not in good enough shape? Did you trip over something? There could be something wrong why you didn't make it to that finish line at the same time the other. If a signal doesn't make it at the same time as the other signal simultaneously, then the diagnosis is going to say, hey, we think there's something wrong. So we're going to stop you right now. And we're going to make the decision that you have to check out why, instead of just saying, I don't know what's wrong. So I'm just going to hit the bypass button, or I'm going to override it and I'm going to keep going. And then that's when the hazards will happen. E-safety is not a substitute for energy isolation. It's not lockout tagout. Lockout tagout de-energizes everything that you've got set up in your lockout tagout program, because there are instances where you have to keep certain things energized when you're setting up machines, doing maintenance on a machine for troubleshooting. So safety, all the safety devices, the light curtains, the safety switches, those cannot be used. Hey, I've got a safety switch on my machine and it stops. Well, I don't need lockout tagout. And that's a false statement. You still need lockout tagout. There was an instance where someone hit an e-stop because the machine hung up. The person went down to look down the linear track. Well, that e-stop was just stopping the electrical energy. The pneumatic energy was building, and the bearing got back onto the rail and then continued its path and hit the person in the head. It put them in the hospital. They didn't lock out and isolate all of their energy while they were trying to figure out what was going on. So be careful that you make sure that you treat these as two different scenarios. So the first one that we have Non-contact RFID switches. These are going to be most commonly on doors, or if you are frequently removing a panel. If you're having to take off a panel on the back of the machine every day for cleaning and you want to make sure it goes back on, then you may want to put a switch on it. Then you don't have to worry about is someone going to bolt it back on. The RFID signal is a more advanced safety switch, most common that we use, so that people aren't taking the keys that you may have seen, unbolt them and stick them into the mechanical safety switch. They may put a magnet on a coated magnet sensor and trick it and say, yep, my door's closed because it sees metal. These are going to be a lot tougher to bypass. I'm not going to say they can't be, but the way to bypass the RFIDs is if they were to unbolt it and zip tie it to the other part. At that point, it's a lot easier to see a zip tie than inside a CNC machine where they've bypassed it by taking the key and just putting it in, unbolting it off the door. Then you have keyed locking RFID switches, zero feedback, timers, encoders. Basically, where this is important to consider when you're doing it, you can't just put a non-contact RFID switch on everything because, hey, it's a safety switch. When I open my door, my machine will stop. Your machine will, the switch will tell your machine to stop, but if it doesn't have an immediate brake and it has to coast down and it takes 10 seconds to coast down, you are now at that hazard for the next 10 seconds and could still get hurt even though you told the machine to stop. This is where you need to use keyed locking switches so that you have some sort of feedback that says I'm at zero speed, or a timer that says it takes 10 seconds to stop, that when this machine stops, now you can it will unlock the door and let you in. You could also do magnetic locking RFID switches. If you are working with heavier doors, this is a very nice key right here, bull nose, spring loaded, large lead in, much different than the traditional blade style. But if you still want to look at not using this, then they do have magnetic locking RFID switches with high pull strength for those doors. Requirements based on speed as we get into present sensing of safety light curtains, safety laser scanners and radars, and safety switch mats. It's going to be 60 inches per second. So again, right device for the right application. You can't just say this is going to be a lot more convenient to just put safety light curtains on the machine, then I don't have a guard in my way. Well, if your machine takes a second to stop, those light curtains have to be 5 feet away. And I've been in a lot of factories, and most people don't have the luxury of 5 feet. So you have to make sure that your machine stops fast enough. If it stops in a half a second, then you only have to be 30 inches away. When you're talking about laser scanners and radars, again, you have to talk about the safe distance of how far I am away from the machine. Safety switch mats, same thing. The thing to be cautious of is people think, oh, 3 foot reach. So as long as I have the scan zone out 3 foot, then I'm good. Well, the problem with safety laser scanners and switch mats with saying 3 foot is enough is I can put my toes outside those 2 zones, lean over the machine and hold on to the machine while I use my other hand to adjust it and then push myself back up. And because they're 2D planes, the machine won't trip because the scanner won't see it. Safety radars is a newer product out there that looks at a 3D area. So it's a 3D version of a laser scanner. That's going to be a lot harder to defeat because of the 3D plane instead of just a 2D plane with the scanners and the safety mats. So out of all of these electronic safety devices, just make sure that you're using the right one for the right application, because it's not one size fits all. And there may be some where you're going to use two in conjunction. Having a little more of an in-depth look at the access protection or the restart prevention, it's commonly referred to as presence sensing. That's going to be the area scanner and the 3D safety radar. So in these areas, becoming a lot more common, especially in areas where there's a lot more high traffic. If you got robots, AMRs, if there's blind spots, if it's forklifts, overhead cranes. Overhead cranes, a lot of times will take out a light curtain. Area scanners and radars can be tucked away in the corner and scanned out. So these are just a couple different applications that you can do with scanners and radars. And then you can see there's a warning zone before you actually get to hazardous zone where it's going to stop it. Same thing here on scanners. And then you just program your zone for where you need to be. Here's another example of the scanner. That's going to be as I'm approaching that I've got a warning zone and a hazard zone. And then you can see over here in the robot cell, you can see radars all the way around the robot. So let's say my door is right here or back here. If I look over here and say, well, when I went to lunch, the machine was running. I came back. I'm not sure why my machine's running. So I'm going to close the door. I'm going to start the machine up. Well, if this person is crouched down behind the robot and this person doesn't go in and look as to why the machine stopped, there had to have been a reason, then the robot could start back up if there is no presence sensing on the inside that says, I'm not letting you start this machine, even though you closed your door, because there's someone back here. When you're dealing with non-robotic applications, there's two words, it's should and shall, and they're very different, but very similar. Should is the regulation says you should do this. It's a recommendation. You should put additional protection in there. So if I have perimeter guard and I can go inside the fence, but it's not a robot, it would probably still be a good idea, best practice, to put a laser scanner in there to see if someone's in there in the blind spot. When it's robotic cells, it's shall. It's because robots are a lot more dangerous. You need to put presence sensing in anywhere that you have a blind spot so that no one is getting caught inside that cage. And then good practice would be putting stack lights, because these lights are invisible. A lot of times when something is tripped, people don't understand, well, why is my machine tripped? Well, maybe I'll override it. I'm just gonna put it in manual mode and still run it, because I don't know why. If they see this light on, then they know one of these devices is tripped. With presence sensing devices, we talked about the speed and the distance. You want to be looking at your stop time measurements. It's critical. It's how fast, the 60 inches is basically how fast can a human move or extend its arm, run at it to get into the hazard. And it takes a human will move 60 inches for every second. So if you have physical guarding and you run at it, you're going to get stopped. If you run at light curtains and you break through it, it's not going to stop you. You're in there. So you have to make sure that you're using the right tools. And to do that, you want to use some sort of stop time measurement tool that you can put on the machine to give you what that is. When it gives you the time, it stops in 0.1 seconds or 500 milliseconds. Well, now I can go ahead and plug that into a formula based on the response time of my devices, and it will tell me I can be 12 inches away, 30 inches away, 5 feet away. If it's 5 feet away, I don't have the floor space. Well, now we're going to put some physical guarding up. there's a basic formula that we use to get that stop time distance. Then the third piece, we had the mechanical guarding, the electronic safety devices, and now we move on to the safety rated monitoring devices. These safety rated monitoring devices are the devices, the brains with the redundancy that talks between the safety device, the switch, the scanner, the radars, and the machine brains themselves. That's the thing that's asking the question and making the decisions. Should I keep going or should I not? You have simple safety relays. These are going to be used in simple applications. I'm just going to use a safety switch because when I open my door, my machine stops. When I break a light curtain, it's going to stop. I'm not doing anything fancy. I'm not doing any timers. I'm not having it make any kind of decision. And then safety controllers, if you needed to make a decision of, I need to wait until I get feedback from the PLC or the brains of the machine before I can make this decision. I need to program in a timer. I need to do something that tells all of these switches, these doors, these lights, a little bit more infrastructure that this safety controller would have some brains in it. And then something if you have a lot of devices on your machine that you want to control a lot more methodically, then you can use safety PLCs. The thing to be careful of, standard PLCs are not approved safety devices. So when someone says, I have the machine has a PLC, every machine should either have relay logic or PLC. That is what's telling the machine how to operate the machine itself. That's not telling it to operate safely. A safety PLC is telling it to operate safely. So if they say, I have a PLC, do you have a safety PLC or do you just have a PLC? If it's just a PLC, that is just your computer telling the machine how to run. Safety PLC, safety controller, safety relay is what is required to do the checks to make sure you are running safely. I'm not going to go into all of these. You guys will get the video and the PowerPoint, but I'll run through this real quick. Basically, it's the way you monitor everything is going to determine what category level you are. You want to be a category 3 or category 4, where it's the dual channel safety monitoring. So the parallel lines, the simultaneous decision making, that's going to be category 2 and category 3, category 4. Category 2 we want to stay away from. That's going to be single channel. It's going to periodically check. It's only going to check one line. And there could be something wrong somewhere else on the machine that it just may not catch or catch in time. So we make sure that we are designing the circuits that they're hitting the higher category levels. So this is going to sum up everything that we just talked about in pre-configuring a safety enclosure. So you've got your electronic safety devices, and those are going to go to your safety monitoring devices. So you've got your switch, your light curtains, whatever that is. You're going to send it to a power supply and a safety relay or controller. And then you're going to send that, and then you're going to, that's the basically what the inside of your control panel may or may not look like. But this is one that we've done where we're putting in the safety relays. We have a drive motor, a series of drive motors in there, and it's monitoring the electronic safety devices. What we do with this is it's a pre-configured enclosure so that it's not going inside your machine controls. We recommend a pre-built enclosure for a couple of reasons. One, it's for better troubleshooting. When you have an issue with a safety circuit, you go right there. Number two, these are typically low voltage. Most of the devices today run 24 volts, or you have 110 coming into the box. Then you don't have to worry about getting into your control box that could be running 480 inside that box and need extra compliance with arc flash and things of that nature. So a lot of times the devices will run into this pre-configured enclosure, and then it is then sent to your computer or your control panels to trigger whatever that stop behavior is. So you have your physical barriers, then you have your safety devices, then you have your monitoring devices, then you have your control output devices. Could be a contactor, could be a drive motor, whatever that is. And this right here will then give you a controlled, reliable system. It's all determined on what components you use, how you wire it, where everything is located, other components on your machines, the type of output devices you are using will determine what category level of that reliable system. But with the physical guarding, using the correct safety devices, not just a blade style mechanical switch, and you're monitoring properly, you're not sending the switch straight to an emergency stop, and you're not monitoring it, and you have the right controller or the right output devices, then you can have a reliable control system. Completed units. You can see here, this is what we talked about with the should is best practice. If there's blind spots on a non-robotic application, consider putting a laser scanner, a safety radar, something in there that if I go to lunch and I come back and I go to the front of the machine and just hit the start button and someone's inside because the door closed or someone hit the reset button, that's should. Shall, if there's blind spots in a robotic cell, you want to make sure that you're not only doing the fencing, but you're also doing the presence sensing devices. The other thing I like to discuss is we all change our oil, rotate our tires, repack wheel bearings, a number of check the belts. You want to make sure that you're keeping your car, your machine, whatever, in tip-top shape. Make sure there's no failures. But a lot of people neglect doing preventive maintenance on machine guarding. You want your machine guarding to last as long as your machine in theory, so that people stay safe. So whether people swing doors shut and it starts to sag, your frame weakens, or a forklift hits it, or they've used the wrong solution to clean polycarbonate, there's a bunch of dust on your wire mesh, whatever that may be, you want to set some sort of schedule for preventive maintenance. I see some people doing it once a month. Sometimes it's once a quarter. A lot of it has to depend on your environment. And then stocking a few parts in your maintenance department. A lot of the products that we use are all standard products. We try to keep our catalog of part numbers smaller so that we can get them out quicker. And then the customers would also stock, depending on how critical it is. If that part is damaged or goes down, maybe you stock a couple safety switches. But if you find someone cut a hole in the wire mesh, maybe you are okay waiting a day. Maybe you want that wire mesh so you can swap it out right away and it's in your tool crib. So you want to have some sort of program for preventive maintenance, keeping your machine guarding up to standard. And then that brings us to the end of this PowerPoint. This here is a few areas if you want to learn more about machine guarding types, get ideas. There's a gallery of photographs of installed projects. There's links to YouTube, which shows a lot of different videos. One of the videos is how to use the gotcha stick that we talked about for the guard openings, for the distance to the hazards. There's a LinkedIn button that you can go and follow us on LinkedIn. We do a lot of maybe a Tech Tuesday There's maybe a podcast that talks about different types of machine guarding that you can listen to. There could be OSHA fines that other facilities have been faced with because of a certain type of incident. Unfortunately, those things become idea generators of what can I do. So there's a number of things that can help you determine where do I go from here, so you're not crippled by decision making on where do I start. And then certainly give us a call. You can email us. There's forms on our website, and then we can discuss how we can help you. But the purpose of this training today was to really arm you with the knowledge of what should I be looking for, what should I be looking at, what kind of questions should I be asking, what do I do if my guard is falling apart? Am I using the right tools for this application? So here, if anybody has any questions, you can drop them in the chat or raise your hand, and we can bring you online and answer any questions that you may have. Well, if nobody has any questions, I want to thank everyone for joining. Hopefully it was helpful to you guys and will be helpful down the line, whether that's you guys internally, training that maybe you can do, maybe something you can share to new employees that are coming in so that they know what to be aware of, or something that we can collaborate with you on to help you improve your safety in your facility. After this meeting, I will work to put together the link to the video, my contact information, the PowerPoint in a PDF format for you, and then a discount code that if you want to have us come out and do a guarding assessment of your machines, then we can do that as well. So if no one has anything else, appreciate your time today. I know it's very valuable. And you guys have a great day and hope to talk to you soon.